We're back with another payments video, and in this video we're going to talk about a topic that is a bit advanced, but it's actually easier to implement than you think, which is subscriptions payments. We're going to be using Cybersource Payment Gateway APIs to collect the card information, tokenize it, run it through 3DS, and then do a recurring payment. And the way we're going to do that is that we're going to create a recurring payment engine that check which user is due to pay today and then trigger the payment for that user using Cybersource merchant initiated transactions. I'll keep the talking to a minimum and show you the demo like we always do in these videos. Here on the right, I have a payment form for a subscription payment page. Here it says subscribe for $20 a month, and it asks you for your card information. So you enter your card information, and then it's going to prompt you to do 3DS authentication. That's when you receive a one-time password on your phone via SMS, and then you have to enter that in the website to confirm that you're actually the one using the card. Hit submit, and then after verification, it's going to do the first payment. That's first $20 a month. And then it's going to tell you you're subscribed. And then it's going to tell you we already charged you for this month, and then the next charge is going to be next month, and this is the card that you're using, and you can cancel the subscription here if you want. I'll show you how we implement this step by step, but we're only going to be covering how to do recurring payments in this video. So if you start from scratch, there are other videos that I have that you should watch first. You need to know how to implement Cybersource microform to collect the card information and then tokenize it. And you need to know how to do 3D Secure with Cybersource, which I also have another video on, also link in the description box below. And you need to know how to create tokens out of the cards that you collect, and I also have another video for that. Before you watch this, you need to know how to do these three things: collecting card information securely, 3DS, and tokenization. I'll link my videos for all those tutorials in the description box below. But if you're already familiar with that and you want to just jump to the recurring payment implementation, keep watching. Okay, and for the subsequent payments, the way we simulated that, we simulated by creating a simulated timeline where every minute that passes is a month. This is how we can test this without having to wait a month for each subscription. The way I do this is with this API, I tell it when the simulation starts, the day and the time. So right now it's 12:50. I'll put 12:51, and then every minute that passes after 51 is a month. Okay, so the simulation started 12:51, and right now it's 12:51, so I gotta wait 1 minute, and then I'll run my recurring payment engine at 12:52, and when that happens, it's gonna charge the user for the next month. Okay, it's 12:52. I have this endpoint to simulate my recurring payment engine running. When I run it, there you go. It checked if it's a month has been passed, a month, which is a minute, and then it charged the customer a recurring payment, and this is the details of my recurring payment. And here on the user's page, you can see them being charged for December, and then it says them the next charge is at same time next month. So this is the demo. Now let's go ahead and work on the implementation from the scratch, step by step. We're starting here with a new project from the scratch. I have a payment page here that collects the card information and then perform 3DS and then create a transient token that can be used to pay within 4 minutes. So just to show you what that looks like, you enter the card information, you hit subscribe, and then you're gonna get 3DS, and then you get this big string over here. Nothing changes in the user database. You're gonna take that big string over here. This is what I mean by transient token. You're gonna take that and then paste it here in this API request and send it. And what this API request will do is that it will perform the initial payment of $19.99. It's gonna create a token using the card that was used for the initial payment. That token is what you're gonna be using for the subsequent payment. This is the token that was returned. This is what we're gonna save in the user database and use in subsequent payments. And this initial payment will also give you the network transaction ID, which you can find here. You'll need to store that and reference it in the subsequent payments. So this will be our first step, is to build an API that do that initial payment, store the details like the token and the initial transaction ID in the database, and also set the date timestamp for the next payment next month. So let's go ahead and implement that. Okay, now I'm switching to my API project file. And here I installed my dependencies, my Firebase admin library for my database and my other Firebase stuff. Firebase is my cloud provider. That's where I host my endpoints, where I store my data and so on. This library is Cybersource Auth, which I created, which helps you authenticate your Cybersource requests easier. Course for cross-origin issues while testing. Axios for my API calls. Okay, now my first step would be to implement here this API call that I showed you guys earlier. Let's go ahead and do that. Wrap everything in a try-catch statement. Catch your errors if you get them. Get your credentials. Now, in this demo, I'm hard coding my credentials, but you should not be doing that. This is just for the demo purposes. You need to be either storing them in environment variables or a secret key manager, which is better. Now I'm getting my input from the client side. Now for the amount and the currency, again, this is another thing that I'm doing just for demo purposes. Do not collect that from the client side. You should get that from your database somehow, whatever way you prefer. So once you have all of that, you need to generate a random string for your request, and you need a method for that. I'm gonna be using this simple method over here that generates a random string. You need to also define your request path, this one, which is the one here in our API. And now you can use this Cybersource Auth library to create your request headers for the Cybersource API request like this. You put on your values, and then it's gonna spit out the request headers, which you can plug into Axios. But first, let's not forget about the request data. This will be this. It's the same request from earlier. You put your reference here, you make sure that you capture the payment. And few very important indicators that you need to do for recurring payments is that you need to have authorized options, initiator, credentials stored in file set to true, and type set to customer, because the first payment is always initiated by the customer. And here in the action list, you set token create and you tell the gateway which information to tokenize. Here I choose to tokenize the customer information, payment instrument, which is their card, and instrument identifier. Payment instrument, which is their billing information, and instrument identifier, which is their actual card. Your order information, again, get the amount and the currency from the database, not the client, and the transient token that you receive from your client side through the microform here, like I showed you earlier, and your authentication data. You put that all together, and now you can send your API request like this. And then after you get a successful response that the payment was processed, now you need to store some data and then push it in the database and then set the date for the next payment. So this is what I get from the gateway. I store the token ID. This is the actual token that we're going to be using for the recurring payment. And I also get the network transaction ID, which I'm going to need to reference in the subsequent payments. Now I need to define when the next payment is going to take place and get the timestamp for that. Here I created a method for that just gets the date incremented by a month and then return the timestamp for it. This timestamp is going to go to my user's database entry, which then the recurring payment engine is going to use to know when to pay. Okay, now I need to store all that in my database in the user's entry, the user's document. And my user here is going to be just Nawaf, just for demo. Here I got to set the user is subscribed, set the token, the card on file, and the initial transaction ID that I got from here, the next charge date that I got from here, same time next month. And then I gotta set a flag called renewal to tell my application that this user is gonna renew the next month. And it's gonna be important for canceling subscriptions later, which we're gonna talk about in a bit. Then in a separate database, store the transaction that just took place. Here's what you need to highlight in this. You need to have an order identifier. You need to have a transaction ID that you can reference across your application. This is what I'm using as my document ID. Who did this payment belong to? Was it initial or recurring? Status, timestamp, network transaction ID, approval code, amount, currency, and then the gateway ID that ties this transaction in your database to the record in the gateway's database, and the card used, token ID. And then after you're done with all of that, you're done with the API call, you can return a successful response to the user. Now let's go ahead and test this in the emulator. Here I need to generate a new transient token with the microform. Okay, there it is. I grab my transient token and I'll go to Postman, paste it here and send it. Let's see. Now, after this is sent, I should get, oh, I got an error. And here it looks like it did get stored in the database for the users, but it didn't get stored in the transaction. So we have a problem in the transactions request here. It's the user ID, not defined. So I fixed that. Now let's try again. There you go, subscription successful. And here we should see our entry in the transactions collection. There you go. This is the transaction that we just did, the initial one. And the user document is now updated with the subscription information. Now let's go ahead and implement this in our client side. Okay, it's deployed. Now let's grab this function URL, and then we're gonna go to the component that renders the microform over here. Right now it doesn't do anything but just log the transient token in the console because I commented out the payment method here. So I'm gonna uncomment this out and go to it here and put my URL here. Again, do not set your amount of currency in the client side. This is just for the demo. But basically what happens after this API is called and the result is returned is that this callback is called, which we read over here. And here I just say payment's done. I print out the result in the console, and then I set the state variable subscribe to true so I can display it in the subscribe page instead of the payment page. So let's go ahead and test that. Get the OTP, submit. Then payment is done. Now it's switched to the subscribed. You are subscribed view here. Cool. Now here, this is all just hard-coded dummy data. The next step for us would be to instead read from our database this information and just display it here. So let's make an API for that. Back to my API project folder. Okay, we're gonna implement it right here. Okay, in this API, we're gonna first define the user ID. No off, so we can query everything using this user ID. Then we need to query Firebase to get all the documents in the transactions collection that belong to this user ID using this method, which we're going to implement now. That method will look like this, just a Firebase query, find transactions documents where the user is equal to the user ID that is given, which is no off. And then that's going to return it as an array here, which is stored here. Next up, we need to get the user data. Like this. This is again just a Firebase query, get the user document and get its data as a JSON object. Next up, we need to get the card and file details like the last 4-digit numbers, the brand, the expiry. And for that, we're gonna need a Cybersource API call for that. The API call looks like that. It's a GET request. You just slap the token ID at the end of it here, send it, and then you get the card details here. You're gonna find the expiry here and the type of the card as a number. 1 is Visa, 2 is MasterCard, 3 is Amex. And you're gonna get the PAN, first six digits and last 4 is here. So we're gonna implement that in our server. And it's gonna look like this. We initialize everything like we did before with the payment call. We use create headers again. To create the headers, we send the GET request. And then we create an object called card and file, which contains the month, the year, the type. And we have a method here that gets the type based on the number. And that's just a bunch of if statements like this. And we get the last 4 digits. And then once we have all of that, we can respond to the client side like this with all the data that we gathered. Let's go ahead and test this in the emulator and send the request. It's gonna pull everything from the database and then display it neatly like this. This is all the information from our database that is pulled from Firebase here. This is the user details, this is the transaction details, and then the card information is not here, it's in Cybersource. Let's implement this in the client side now. Switch back to the client side. Now here, on the client side, we need to add some things. We need to add some state variables from the API that we just implemented. One that stores the list of charges, the one that are here. Currently, it's dummy data, so let's just get rid of this. The next charge date, the card and file details, and the renewal, whether the user is going to renew or not. We also need to use effect. This method is going to call our API as soon as the component renders. We're going to create a method inside here that calls that API like this, calls that API, gets the data, and then sets them as a state variables. And if not, then it caches that error. Okay, now let's go refresh. We forgot to import Axios here to call the API. And I'm getting this error because I'm receiving the times and dates as timestamps, and I need a way to format it to actual readable date and time. So I'm gonna just use this simple method to fix that. This gets used here. As soon as I receive the timestamp for the next charge date, I convert it to a readable format and I set it as the next charge date. Save, and now it should look different. There you go. After it loads the user status, this is what it looks like. Okay, now we need to change the hard-coded data here. Let's start with this next charge date at 23 November 2025. That's not correct. It should be December. There you go. That fixes that. Now, same thing with the card on file. We're gonna wrap all of that in this condition. If card and file is not null, then we can display all that stuff. And here we're gonna replace all this dummy data with actual data from this card and file object. Okay, refresh. Better. Lastly, these charges. This thing loops through my array and prints out the date for each charge. Now we can refer to the format here. How do we get everything? here in Postman, we see that we're getting the time from timestamp here. So we need to change this. There you go. Now it looks better. We do the same thing with the amount. Actually, amount already looks good. Okay, cool. So now we're displaying data correctly. That's it for that. Now we need to work on the most important part, which is the recurring payment engine, how to trigger a payment every month and then how to test that. Okay, we're gonna implement that here. Now, for testing purposes, I'm just gonna implement this function as a regular API just to test it. After I demonstrate that it works as a regular API, I'm gonna change it to a recurring function, a scheduled function that runs every minute or so. Okay, so let's go ahead and implement the recurring engine. This is the part that you all been waiting for. Now keep in mind, this is gonna run every month, but for the simulation, it's gonna run every minute. So first thing you need to do when it runs is that you get a list of all the users you have. If it's empty, then shut it down, skip it. Then you need to get the current time. In production, you're gonna just read the time. You're gonna get the timestamp for now. But because we're testing, we're gonna need to get the simulated time instead. And we're gonna do this like this. Advanced time, simulated time. And here we created a simulated time method. What it does is that you tell it when the simulation is starting. For example, right now it's 1:42. So let's say simulation is gonna start 1:45. Okay, and then what this will do is that it will treat every minute that passes after this time as a month that passed and return a timestamp that reflects that. So for example, if it's right now it's 1:43 p.m. when it's 1:44 p.m. the system is going to read it as 1 month passed. When it's 1:45 p.m. the system is going to read it as 2 months that have passed. And this is just done through simple math here. All you got to do is count how many minutes have been passed since this time, and you multiply the minutes by the number of milliseconds in a month, and then you add that to your current timestamp to advance it by a month. And this is what we're doing here. So we read that, and then we loop through our users like this. It's a lot of code. Let me show you what's happening. I loop through my users and I check if the user is subscribed, and the next charge date that they have in their profile, which is the time to renew the subscription, is less than the current time or the simulated time in case of testing, then I will charge them. But first I'll check if they're set to renew the subscription. If they're not set to renew the subscription, then I'm gonna instead cancel the subscription. Otherwise, I'll go ahead and charge them for the next month. And the way we're gonna do that is gonna be using this API call. It doesn't look very different from our previous payment API call. Here, we just set commerce indicator to recurring. We say that the initiator type is merchant, and we say that we're using stored credentials. And we say that this is a merchant initiated transaction and give it reason value of 7. 7 means recurring payment. And then previous transaction ID is gonna be the network ID that we stored in the first API call, which is this one, this value. Then you set the amount, the currency, and then you use the token here to pay instead of the transient token, which you already have stored in your profile here. Okay, you put that all together. You get your credentials again, hard-coded just for the demo, the amount, and you also generate a random string for this payment like you did with the initial payment. You get the card and file and the initial transaction ID from the database, and you put all that in one API request like this. Request path, headers, you send the API request, and when it's successful, then you get the date for the next charge. You get the timestamp for that, the same way you did in the initial payment. But here in the simulation, you need to feed it the advanced time. And it's gonna give you a month later from this simulated time. Where in the initial payment, you just give it the current time, as you can see here. I hope that made sense. If it gets confusing, let me know in the comments and I'll try to explain as much as I can. Anyways, after that payment is done, then you update the user database entry with the next charge date for the next subscription, for the next month. And then you add this recurring payment to the transactions database. Here, what's gonna be different is that you're gonna say recurring transaction instead of initial, and the rest is gonna be the same, pretty much. So you're gonna do that with all the users that you loop through in your database to renew their subscriptions, and that's how you basically create the recurring engine. In production, instead of using advanced time, here you're just gonna use the current timestamp. So new date, You won't use advanced time. Anyways, once that is all done, you respond to the client side if you're testing this, but in a real scheduled service, you don't need to return anything to the client because there's no client. Now let's go ahead and test this. 150, so let's set that accordingly. Okay, now let's keep an eye on the database to see if a transaction is gonna get added. Let's wait a minute and then run it. Waiting for it to be 151. Okay, run it. There you go, it worked. And then when we check our user interface, you can see the new transactions here. When you see the next charge time has been updated. Now, you know what? Let's change this to a recurring function and just sit back and wait and see how it charges every minute. Okay, I deployed the recurring engine to cloud now, and it's just gonna now start running on its own. So let's sit back and relax and see how every minute a new transaction gets added to the database. Okay, you can see like ever since for the last few minutes, 4 transactions or 3 transactions have been added, and another one is gonna keep getting added every minute. So this means our recurring payment engine simulation is working right now, and it's looking great. Now, to make the testing faster, you can change the increment to be, instead of every minute you get a month, you can make it like every 5 seconds or 10 seconds. But that might be too fast, but you get the idea. Now it's November. I believe another transaction came in. Yeah, check this out. There you go. Okay, so that's how to implement the recurring engine. And now for the cherry on the top, the last step here, which is the cancellation. When I cancel, I don't want to just remove the user subscriptions and access right away. I want to give them till the end of the next charge date where they can still be subscribed or have access until the system attempts to renew their subscription, finds out that they're not set for renewal, and then cancel the access. This is the same thing when you have an Apple Store app that you cancel and it tells you you still have access till... We're gonna be doing the same thing here. Okay, and we're gonna be implementing this here and then implementing it in the client side. Now with this, it's gonna be very simple. All we gotta do is just set the renewal flag to false to unsub the user. And what's that gonna do is that when it's time to renew here in the recurring payment engine, where here, it's gonna try to renew for this user, but then it's gonna say, oh wait, the renewal flag is set to false. Then instead of just paying again, just set the subscription to false to close the access for the user since their subscription expired. So that's all we gotta do here. Now let's deploy this and use it in the client side and show you guys how it works. Now, when the user has canceled and the renewal is set to false, but their subscription still haven't expired, here we wanna say instead of next charge at next month, December 16, we say subscription expires at December 16. So that's what we're gonna need to change on the client side. Now, earlier you saw that we created a state variable that stores the renewal flag, and this is gonna be used here. We're gonna do if renewal is true, then we're gonna put this text. If it is false, then we're gonna say instead access expires on the same date. And then this cancel subscription button over here, now right now it says set subscribe to false. We instead wanted to call that API. So let's change this to handle on sub, and this is just gonna call this API. Make sure it's async. See how many subscriptions we got so far? A lot. Okay, my function got deployed, so let's go ahead and try this. Now when we hit cancel, we should see renewal turns to false and is subscribed is still true. There you go. Now it just says access expires in this date. Now we need to wait 1 minute, and then after that, a month would have been passed, and then this is gonna turn to false, and then we lose our access. There you go. Blinked, and it said now false. Now if I refresh the page, I'm not gonna get access. It's gonna ask me to subscribe, and that's it. This is how you implement a recurring payment engine using Cybersource Payment Gateway APIs. It's long, it's complicated, I know, but this is one of the most valuable use cases in businesses, and big merchants like Netflix, Spotify, and so on, they rely on this a lot. This is their whole business. And now you know how to implement it too for yourself if you need this in your business or your application or whatever. So it was a lot. If you have questions, I know. leave them in the comments. If you enjoyed this video, if it was helpful, hit like and subscribe for more content like this. And if you want to support the channel and get access to the full source code that we used in this video, so you don't have to build it by yourself from scratch, check the Patreon link in the description box below. And thank you for watching, and I'll see you next time.